Good evening, Avnija. So, have you done image formation by concave mirror?
Yes, sir. Yes, sir.
So, we were left with two of the ray diagrams. We had left two ray diagrams which we will be completing today from the concave mirror, and we have left the ray diagrams of convex mirror. Then after that, we will be finding out. We will be using the mirror formula, finding the magnification. So, this is our target for today. Let's start quickly with concave mirror, the two diagrams which I gave you homework. Have you done those?
सर सेकंड वाला हो गया था, फर्स्ट वाला नहीं हो रहा.
Okay, first one means when the object is placed at focus.
Yes, sir.
Okay, so let's see them quickly. Abhinav, Abhigya, and Aryan. Okay, so in your school, this chapter is, I think so in some of your schools, maybe this chapter is complete. Okay, but still we will be learning so that we do not forget any of the things. So see, I told you yesterday that while drawing the diagram, you have to use all the geometry boxes. Your all the instruments of the geometry
Good
boxes.
evening, sir.
Yeah, good evening, Abhigya. Good evening. Sorry, it is Shubhansh. Oh, Shubhansh. Okay. So see, this is the ray diagram for concave mirror object placed at focus. So as I told you, you will be using your compass to draw the concave mirror. Use your compass to draw the concave mirror, and wherever you placed the compass, mark that to be the center. So you are supposed to mark this point as center. Mark center. Draw the principal axis and also mark here pole and focus. So yesterday I told you that you need to take the help of ruler also. You need to take the help of ruler to plot the points. To get the points C, F and P. The F should be exactly in between, or focus should be exactly in between pole and center of curvature. So then only you will be getting the correct ray diagram. So now let's put the object at F. So we put object over here at F, and to make the object we make it an arrow. Now from this point we have to consider two light rays. Okay, so see which light rays can we choose. I told you two options are there. I told you three options. So let's try out with the first two options. If a light ray passes parallel to the principal axis, so we'll start from the tip of the arrow. A ray of light passing parallel to the principal axis. So when it touches the mirror, after that it will pass through the focus. So it will pass through focus like this. The second light ray, you can take it either through pole, or the other option I told you that you can take it to be passing through center of curvature. So a ray of light passing through center of curvature may be taken something like this. Okay. So this is the ray of light passing through center of curvature. Yes, what happens to the ray of light passing through center of curvature? Where does it go?
It bounces back on same direction.
Yeah, it goes in the same direction. It retraces its path. You can say it retraces its path. So once you draw it, retracing its path, you will get a line something like this. See, this is how you will be getting. And if you extend them, see, I'm extending them backward also, behind the mirror also. So if you extend these light rays even behind the mirror, so here we observe that the two light rays, they do not meet at any points. See, the two light rays, they are reflected the reflected light rays, they are not meeting at any points. Okay. Here also they are not meeting, and here behind also it does not appear to meet at any point. Both the lines, they become parallel to each other. So in your ray diagram, you should be getting the two light rays parallel to each other. Did you get the light rays parallel to each other?
Yes, sir.
Okay. So if you have got the light rays parallel to each other, then you get your light rays parallel to each other. So it means that light rays do not meet at any point. Okay. But in science, we do not say they do not meet at any point. Rather, we will say that they meet at infinity. Okay, meet at infinity. Like we observe Earth and sky to be meeting at certain point. Earth and sky, they seem to meet at a certain point, but they do not meet. So in the same way, we will say here that the light rays, they do not meet, but we will write here they meet at infinity. Now another important point here about the image characteristics. So now we are confused that whether we will write the image to be real or virtual. Since the light rays are not meeting, and we have written light rays to be meeting at infinity. So what characteristics shall we include then? What should we say for nature?
Virtual.
It's real.
Virtual? Yes. What can we say? Since it's not even virtual, it's not even real. See, if we are saying that it meets at infinity, we say that here that the light rays meet at infinity. So they are meeting at infinity wherever they are meeting, but they are meeting. So they are meeting at infinity, and we will say in the image characteristics that image is real and inverted. Okay,
सर
we will say image is real and inverted.
बट सर वो तो पैरेलल है.
Yes, I will tell you. I will tell you. Just hold on. I will explain this.
सर
Image
good evening sir,
is
sorry
inverted.
sir, I joined late sir. uh,
Okay.
Sir, what is this diagram about, sir?
This diagram is about the image formation when the object is placed at F.
Yes sir.
Okay. So your image is real and inverted. Image where it is formed at infinity.
Sir, could you explain yesterday one of the homework you gave, no sir, between F and P? Sir, could you show that as well,
Yeah,
sir?
yeah. So just we have not done that yet. We are just this is the first one we are doing.
Okay, sir.
Okay. This is the first one. Object at F. So image is formed at infinity. Then third one we will say that image about its size. So we will say it's highly magnified. Okay. So let's see what we say when we are highly magnified. We'll say image is highly magnified. Okay, so you can take any photo, any picture on your mobile or on your you take any click, okay, any photo, and try to zoom it as much as you can zoom. If you zoom it a lot, you will not be able to identify the picture. Will you be able to identify the image?
No, sir.
No. You will not be able to correlate the colors. So that is why that is a similar thing we assume here. We assume that it may happen. We can't say that they are not meeting. In our vision, we observe that they are not meeting. But it may happen that they are meeting at infinity. So if they are meeting at infinity, we will call this that image is real and inverted. Whenever the real image will be formed, so it will be formed at inverted. Now, where it is formed, that is at infinity and highly magnified. So we cannot see the image. We cannot see the image because it's very magnified. Just like I talked about a photo. So if you take a click and try to zoom it, so if you zoom it a lot, you will not be able to identify the image. Okay. You take any click and then try to identify, try to zoom, you will not be able to identify what is there.
Sir,
Okay.
please don't erase, sir.
I hope you have understood.
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So this one is your object at F.
Sir,
This
please
one is
don't
for
erase, sir.
object at F. Then the next one, we do object between F and P.
Sir, could you just show that previous, sir? I'm still done.
Just 1 minute. 1 minute. Here you are.
Okay, sir.
Now let's see the object between F and P. Please use your compass and all. And now draw the diagram. So same thing, complete your basic diagram. Center of curvature. Draw the principal axis. Right here, pole F, F and P. Make the shading of the mirror. And place the object between F and P. So anywhere, place the object between F and P like this. Okay. Now use your two rules. Okay. Your rule says that one of the ray of light you can take parallel to the principal axis. The second light or second ray of light we can take passing through center of curvature. So let us take the two light rays. Let this be light ray be parallel to the principal axis. So Aryan, where should this light go?
Sir, it will bounce back, no, sir.
No, it's parallel to the principal axis. So in which direction will it bounce back?
Sir, the like I don't know.
It
Sir,
will pass through focus.
Yeah, it will pass through focus. So we will draw it like this, passing through
yes,
focus. You see, the ray of light passing through focus. The second ray of light you will be taking passing through center of curvature. So passing through center of curvature, the ray of light goes like this, touching the object, and it comes, strikes the mirror. So after striking the mirror, the ray of light will retrace its path. It's something like this. The ray of light starts from the object in the line of the center of curvature, goes and strikes the mirror and retrace its path. Okay. So now, if we observe the two reflected light rays, see the two reflected light rays, they seem to diverge each other. They do not seem to converge, they seem to diverge. Okay. You will find here the distance between them is increasing. Okay. So I will say that they are not meeting. I can't say that the light rays meet each other. Okay. But if I observe from here, now if I observe from here, see if I observe from here, then see. So while observing from here, I will be able to see it will appear to me that the light rays, they are coming from a common point. Right? See, this light ray and this light ray, they are coming to my eyes. So it will seem to me, it will appear to me that the light rays, they are coming from a common point, and to obtain that common point, I have to extend the light rays backward. I have to assume. So this I am assuming that the light rays are going backward. Light rays are going backward, backside the mirror. Light rays cannot go behind the mirror. Okay, but I'm assuming that they are going back behind the mirror. They are not actually going. No light ray can cross the mirror. Okay, so they are not crossing. Now from this light ray also extended backward, and you can see if they are extended backward, they appear to meet at a common point. Okay, in your notebook, while drawing this extension, see here everyone, when you are drawing this ray of light extended backward, then you have to represent it with dots. Whenever you have to show the extensions, so extensions should be represented with dots. Here I can use colors, but you should use dots to represent.
Sir, could you explain this diagram, sir? I didn't understand.
Which part?
Sir, sir, you've seen that, no, sir, but that extensions will be seen, sir.
See, extension means, see the ray of light. This is the first ray of light we have taken, which passes parallel to the principal axis, and after reflection, it comes back along the focus, right? The second light ray we have taken in the line of center of curvature, that means in the same line as the center of curvature, going to mirror. So it will retrace its path since it is in the line of center of curvature. So whatever light ray is in the line of center of curvature, it will retrace its path. Okay, so it retraces its path and comes over here. Now here we observe that the two light rays, they are diverging. The two reflected rays, they are diverging, so they cannot meet at any point. Okay, so they can't meet at any point. But if two light rays are coming to our eyes, something like this, so our eyes will observe them to be coming from a common point. Okay, so they seem to come from a common point, and hence we extend these reflected light rays backward. So these two reflected light rays, they have been extended backward with these dotted lines. Okay, so you have to make them with dotted lines. Now where they meet, at that point you will be drawing your, here you will draw your image. So now see, you will be getting a virtual and erect image here. So see, the ray of light started from the head part, and when they meet again, so it will be the head part. You will observe here the part A dash, B dash corresponding to the parts A and B of the mirror. So Abhinav, are the light rays actually meeting?
No, sir. They appear to meet behind the mirror.
Yeah, they appear to meet behind the mirror, but they are not actually meeting.
Yes, sir.
Okay. So image characteristics, if we talk of their nature to be real or virtual, so what can we say?
Virtual and direct.
Virtual and erect.
Virtual and erect.
Yeah, it's virtual and erect. And what about the position?
Behind the mirror.
Behind the mirror.
Behind the mirror.
Okay, it's found behind the mirror.
Sir, diminished.
Then what about size?
Sir,
Enlarged.
enlarged, sir.
Sir, enlarged.
Enlarged.
Size enlarged. Okay. So I hope you have got all the characteristics of the images formed by the concave mirror. Okay. So just in short, we'll be keeping up all the points we will see all the points which we discussed. Okay. So just we will try to list all the points about the. Okay. About the image formation by concave mirror. So let's list out all of them. So we will have the different characteristics. We will have the placement of the object. So object position, we write here object position, and here we write characteristics. So first we write nature, then we will be doing position, and then we can write size. Position and we write size. So quickly we have a quick revision for all of them. When the object is placed at infinity, so what is the nature of the image?
Real and inverted.
Yeah, nature is real and inverted. You have real and inverted. Okay. What is the position?
Formed
It
at
is formed
infinity.
at forms
At F, and size?
highly diminished.
Highly diminished. Okay, very good. It is highly diminished. Then when it is placed beyond C,
Real and inverted.
again real and inverted. It is found between F and C, or between F and P, where it is found?
F and C between F and
FNC.
Between F and C. Size?
diminished.
Diminished. Okay. Then when it is placed at C,
Real and inverted.
real and inverted. Position of image
At C.
at C. Size?
Same size.
Same size. Okay. Then you have object placed between C and F. So when it is placed between C and F, then again real and inverted. It is
Beyond
enlarged.
C.
Okay, so it is beyond C and enlarged, right? Now we have at F. So you have object at F. When the object will be placed at F, so image is real and inverted again. And where it is found?
Formed at infinity.
At infinity.
At infinity. Size?
Highly magnified.
Highly magnified. Then between F and P,
Virtual and direct.
it's virtual and direct. Position of image behind the mirror, and size is enlarged. Right, Aman?
Yes, sir.
Okay, you got all the points?
Yes, sir.
Okay. Now see, just if you correlate all the things, you should also be able to correlate all the things. So what can anyone answer? Just think for it 1 minute and then answer. Okay. What happens to the position of image when the object is moved from infinity towards the mirror?
Sir, the image will get bigger by the position.
Yeah, the size of the image increases, and what happens? What happens to its position?
Sir, it will keep getting closer to the mirror.
Away from the mirror. It will keep getting away from the mirror. Initially, it was formed at F. See, initially it was formed at F, then between F and C, then at C, then beyond. Finally, it reaches infinity. So, image moves away from the mirror. When object moves towards the mirror, image moves away from the mirror. Okay. Okay. So now see the next we have again, now we'll see image formation by convex mirrors. Zoha, Sudhanshu, Shubhan Singh, Meher, turn on your cameras. Okay. So the next image we have to do image formation by convex mirrors. Do practice all these ray diagrams. See, we have seen that the concave mirrors, they have the ability to form enlarged images. They can show virtual, erect, and enlarged images. Also, they have the ability to converge the rays of light. Okay, so just a little bit discussion about these concave mirrors. So concave mirrors, they have the ability to, first of all, they can converge the light rays. Convert the light rays. Then second thing they can do is they can form virtual, erect, and enlarged images. Then they can form real images. So these are the things that we should keep in mind. We will see where to use this. It will be used somewhere. Okay. So they can form real images. Now we will see the image formations by convex mirrors. So how the convex mirrors form the images. So let us see the convex mirrors. So for the convex mirrors also, you will use the same thing. Make the same point as C, the point you used earlier as C. Make the principal axis and mark your pole, focus, everything the same way. But now the shading part of the mirror, we will do on the inner side. We will do the shading on inner side. So you have now, now the shiny surface lies outside the mirror. On this side, you have the shiny surface, and on this side, you have the shaded portion. Okay, so you can see a convex mirror is bulging outwards. A convex mirror, it bulges outwards. Okay, so this convex mirror, it is facing, or its shiny portion is bulging outwards. So this is your convex mirror. Now, first of all, we will see about the rules that will be used. Which rules will be used for making the images for convex mirrors. Okay, so let us see again, the two rules are the same, but let's see how do they work. We have the same rules as we had for the concave mirrors. Okay, but the way they work here. So are your diagrams ready? Aman,
Yes, sir.
are your diagrams ready?
Yes, sir.
So see, prepare your mirror and now let us see the two rules first. It's very, you can say, we must understand the rules which we are using for drawing the ray diagram. So the very first one, if you take a ray of light parallel to the principal axis. So see here we take a ray of light parallel to the principal axis, and this ray of light is striking the mirror like this. Okay. So as we have studied that everyone pay attention here and let your cameras be on. Otherwise, I see it seems as if you're not paying attention. Okay. So if a ray of light is parallel to the principal axis, so it must pass through focus. Okay, the ray of light should pass through focus, but this ray of light cannot pass through focus. So Ionija, why can't it pass through focus? As per the rule, the ray of light should pass through focus, right? But I say it will not pass through focus. Any reason why it will not pass through focus?
Sir, the light ray cannot go past the mirror.
No, it's because it cannot cross the mirror. Simply you have placed a reflecting surface, so it cannot cross the mirror, right? So it will go in line of focus. Now, if you observe in line of focus, so you need to draw this like this, line of focus. So see where the light rays goes. Now, this part, I am just drawing for reference. Actually, how the light ray is coming, it comes like this on the surface of mirror and bounces back from here, goes like this. It does not come this side, but it goes in the line of focus. So understood this point, how the ray of light is being reflected? It gets reflected in the line of focus. In the same line as the focus, it gets reflected. So here you will have your ray of light. This is how your ray of light will travel back. Now, if a ray of light is coming towards center of curvature, so this also, we will draw the ray of light to be coming towards center of curvature like this. So it is coming in the line of center of curvature again. See, it is coming towards the center of curvature. But the ray of light cannot cross the mirror. So it will come here and it will get back. It will bounce back along the same path. Understood these two ray diagrams?
But sir, then image will be formed in that F, no sir, F and C.
We will see how the image is formed.
Okay, sir.
Okay, but here we observe that the light rays, how they are reflected, that how we can apply our rules. Okay, so let's see when we place the object at infinity. So if you place your object at infinity, so this is how it is going to work then. You have a center of curvature, pole, focus. Mark everything, C, F, P, shade the mirror on the inner side so that it will be easy to identify that what type of mirror is it. Now, all the light rays which are coming towards the mirror, all the light rays, they should come parallel to the mirror. So they should come like this. All the light rays, they are coming parallel to the principal axis. So see, all the light rays, they arrive parallel to each other. Now, after reflection, as discussed, each of the ray of light will be reflected in the line of focus. In the line of focus means you should join this point with the focus, join the second point with focus, join this point with focus, and join this point with focus. So they will be all reflected back along the same lines. Reflected back like this, reflected back like this. And just I'll be checking all your ray diagrams for this. Now, since the light rays, they cannot cross the mirror, so we will draw them with the dotted part. Inside the mirror, we will draw them dotted. So see, this is how the light ray appear to meet if the object is at infinity. So yeah, anyone having any doubt in this diagram? So your image is virtual and erect. The light rays, they are not actually meeting. They appear to meet. All the light rays, they appear to meet here. We have obtained the image by extending the reflected light. Okay, so all the light rays, they have been extended to meet at a common point, extending virtually. So image formed is virtual and erect. It is formed at focus, and the image is highly diminished. It's very small. Image is highly diminished. Okay, everyone done the diagram? Okay, so I would like all of you to show your diagrams. All of you just show your diagram.
Sir, not completed, sir. Sir, I'll share
Yeah,
you photos, sir.
complete and show.
Yes, sir. Sir, I'll share you that photo, sir.
Just 1 minute. No, I want to check whatever errors are there. So I want that to see and correct you right now. Right? So that is the thing. Just show the copy state, beta. Show the copy state, Aman. Yeah. Aman, in the all the ray diagrams, all the rays marked arrows. You have not marked any of the arrow. Okay. So mark the arrows. Okay. Next. Next, who is doing Abhigya? Okay. Center pole focus. Okay. On top, just write F, object at F. Right here, object at F. Okay. Next, Aryan. Aryan, you have not used parallel light rays. Your incident light rays are not parallel.
Okay, sir.
See the diagram once more and redraw.
Okay, sir.
Okay, okay. You need to redraw. And who else is there? Ionija. Yes. Uh, Okay, it's correct. But I think while using your scale, you have marked focus where you had placed the compass. Is it?
Yes, sir.
You is it? You have written focus at the point where you had placed your compass.
Yes, sir.
No, that point should be center of curvature. That point should be C, and between P and C, mark your F.
Okay, sir. Okay, sir.
Okay, so and then show it later. Abhinav. Okay, Abhinav, you need to you need, yeah, the diagram is correct. Okay, it's correct. Okay, who else is left? Dhriti. Okay, Dhriti, show. Dhriti. Uh, yes, your diagram is also correct. Yeah, it is correct. Okay, so I think everyone has shown. Is there anyone who has? Yes, Shubhansh. Yeah, Shubhansh, it's correct. Yes, Meher. Yeah, Meher.
Sir, yeah, sir, just a minute.
Okay, image formation. Okay, it's correct. Okay, correct. Also, write down the name of the mirror, right? All of you write down over there name of the mirror also. Convex mirror. We are doing here
Yes, sir.
image formation by convex mirror when object is placed at infinity. So this is a convex mirror. Okay. Now see, as you can see here, as you can see on the shiny side of the mirror, on the shiny side of the mirror, you do not have any focus center of curvature. There are no points on the shiny side. Yes. Can you observe any point on the shiny side?
No, sir.
No,
No.
sir.
No, sir.
So there are just two cases. One case we have when the object is at infinity. The second case we make when the object is at a finite distance. So for the convex, you have only the two cases when the object is at a finite distance. So when you have the object at a finite distance, let's draw the diagram. So you have center of curvature, focus, pole. Now see, you can keep your object at any distance. Okay, so it should be a finite distance. So at any finite distance, you can keep your object. Here, draw the object. Okay. Now see, to obtain the image, let's see here, how can we obtain the image? We need two light rays. So again, the same rules we will see. We will take a light ray parallel to the principal axis. And this light ray, after reflection, should pass in line of focus. So it should pass in line of focus like this. And this side we will just use our dots. Like this. So this is how your ray of light comes and gets reflected. Okay, everyone completed this much?
Yes, sir.
Okay. The second ray of light we should take in line of center of curvature. So that means you need to put your ruler something like this. See, your ruler should be taken like this. Like this. You have to take it between C and P. Like this, you have to take your ruler and then draw the line over here from this point to the center. So this will be in line of center of curvature, and backward through C you will be drawing dotted lines. So like this, use your ruler and make it dotted.
Drawn, sir.
Drawn. Now see, do the two light rays meet? See this light, this was the first light ray. It's going like this. The second light ray is going like this. So do the two light
No,
rays meet?
no, sir.
No. But we can see that they appear to meet.
Yes, sir.
Okay. So see here, the two light rays, they appear to meet behind the mirror at a common point. If extended backward, they appear to meet at a common point, and hence we will get our image at this point. So at this point, we will get the image where the two light rays appear to meet.
Between F and P.
Between F and P, and it is behind the mirror. Okay. So let's discuss the characteristics. Everyone has understood the diagram?
Yes, sir.
Okay, see, we are observing from here. Just 1 minute. Hold on for 1 minute. Okay, thank you for waiting. So see here, we obtained the image. Now I hope all of you must have written up to now, you must have written the characteristics. Okay, is there anyone who is not able to determine the image characteristics?
The
Yes,
virtual.
so I think if everyone is getting, so anyone can answer, anyone can give me,
Sir, it will be virtual. Yeah.
okay. So it's virtual and erect.
Yes, sir.
Sir, it's between F and P. It's formed between F and P.
Okay. Formed between F and P. Very good. Then third point.
Enlarged.
Okay. Formed
Diminished.
between enlarged or diminished?
Diminished.
Yeah, it is diminished. Okay. So these are the three characteristics. Every time when you are drawing the ray diagram, draw the image, draw the diagram, write the characteristics. Okay. So in all these cases, these are the only two cases. So maximum you can do is that you can bring this object very close to pole. Okay. But still you will observe the same thing. You will observe the similar image form. Even if you take it very far off, so then also you observe a similar thing, but the image will be formed at F. Okay, so now just remember a convex mirror. If we list out the characteristics of images formed by a convex mirror, so a convex mirror always forms a virtual image, it never forms a real image. So the convex mirror always forms a virtual image, right? And what about its size? Can anyone comment about the size of the object?
Diminished.
Always diminished. It's always diminished. It's never enlarged. And what about its nature?
Virtual. Erect.
Virtual and erect. Okay. It is always diminished and it is virtual and erect. Okay. Always. So a convex mirror can never form a real image. Now, out of the given mirrors, which mirror can form real image? Which mirror has the ability to form real images?
Only
Concave.
concave.
Only concave mirror, right? All other mirrors can form only virtual images. It's only the concave mirror which can form the real images. Now I give you a part homework. Just go through it and try to get the idea. I think you will be able to visualize. If not, I'll be dealing with it in coming classes. So you should see here. Okay. So you should see here about uses of mirrors. Okay. So this is your homework to find out the uses of concave mirror and convex mirror. Okay. So bye everyone. Good night. See you all in next class.
Thank you, sir. Bye, sir. Have a good day.
Bye.
I see.